And thank you, everybody. Simon's actually my boss, so nice awkward introduction there. So let's get started. Data quality, yes, please. And this is a little bit about me. Today I discovered the border feature in Google Presentation. So you can see I used all of them. So my name, Bovard, is French, Bovard. Doerschuk, my wife's name is German. Tiberi is Italian. I get asked that a lot. And those are the flags, obviously. I'm a senior software architect at Workiva. I'm a returned Peace Corps volunteer I served 2 years in Burkina Faso, which is in West Africa. And I've got BS Mathematics and Computer Science from Montana State and Master of Information and Data Science from UC Berkeley. So with that out of the way, let's go ahead and get started. And obviously, more Ovaltine, please. That's why you're all here, to see jokes about Ovaltine. Well, I did not disappoint you, but this will be the only one, so I'm sorry. All right, so why do we care about data quality? And I'm sure all of you have heard about big data and how awesome and exciting it is. There's an off-cited study from the University of Texas, which looked at Fortune 100 companies, and the median Fortune 100 company, if they increased data access by 10%, that was a measurable 14.4% increase in sales per employee, which is insane if you think about it. If you're on the data team and you can get 10% more of that data in front of your fellow employees, your stock price is going to go up by 14% or more, or your profits are going to increase and your take home. I mean, it's just mind-boggling to think of that fact when I saw it. So if anyone knows more about that study, come talk to me. I'd love to know how they got that number exactly, but it's very cool nonetheless. So data access and usability then kind of is what we get to from data quality. And if you're familiar with the Doge meme, so data, such usable, much access. However, that is just the tip of the data iceberg. And this entire thing is built on data quality. And in the land of data quality, we have lots of sharks. We have ships that have sunken and crashed into trying to make data products on really bad data. We even have a bad actor from the 90s who turned around and got his Emmy or whatever award he gets. And they even have laser beams on their head killing. And that's the last meme in this presentation. I'm sorry. All right, so this is just a disclaimer. This is a solution to maybe a small microscopic point in the data space. There are thousands of things going on, and I'm sure all of you are very interested in this topic. You're going to the presentation, as am I, next, from the guy from Alibaba. I'm very excited to see that. And you probably won't sound anything like this, and if it does, you totally copy. And the TLDR is we're going to solve data quality problems by applying concepts from strongly typed languages. So you can all get up and leave now because you know exactly what I'm going to say, right? All right, so first, what is data quality? And the first thing that any good presenter does is goes to Wikipedia and puts down the definition. There are many definitions, but it's generally considered high quality if it is, quote, fit for its intended uses in operations, decision-making, and planning. And that fits very much with the study that we just heard about, right? If people can actually use the data, they're going to get more value, more sales, more revenue, better business, and off you go on your rocket ship of data. But really, data is quality if it's usable. So that makes a lot of sense. So our focus today in these specific examples is going to be an event-driven architecture in a multi-team development environment. So let's break that down a little bit. So I left a box down there at the bottom that was my notes, so ignore that. However, imagine you're building a presentation app, just like this one, that's used by millions of people around the world. And they're doing things inside your presentation app, like adding slides, deleting slides, sharing the presentation with other people, putting a box or text or saving it, all these different things. And those are all events. And you can think of taking each of those events and throwing them into a data pipeline or a stream of data. pipe-like structure. And that's kind of what we're talking about when we're talking about gathering data here. This is metadata about how people are using your product, and that's kind of the focus of what we focus on today. Is there a question? No, stretch. So, all right, so this will be a case study in 4 acts, and I believe if there are any English majors, it's either 3 acts or 4 acts. It's the common Shakespeare play. But we'll start with common issues, then talk about our solution framework, talk about a specific implementation, and then building on that implementation, what we can do to go further. So, in this data streaming environment, what are some of the common issues we have? So, the first, I posit, is data discoverability. So say we have, 12 product teams, and they're all working on this presentation app. It has to be a really cool presentation app if it's got 12 product teams working on it. But then we want to know, okay, Bovard logged in yesterday and did something in the presentation app. What was this entire day like in our app using this metadata that we're collecting? Opens, saves, what images did I paste in, all that sort of stuff. If I don't have a good kind of data catalog, I'm going to have to go to each individual team and say, hey, Alexander, your team, what are you measuring about your users? And I'll go over to Kevin and say, hey, Kevin, what are they measuring? And my eyesight isn't that good, but I'm sure there's someone in the back of the room that also has something. So we're looking at the whole picture here. And so if you have to go team by team and ask, what are you measuring? What are you measuring? What are you measuring? That's going to take forever, and it's going to change every week or so. Second issue is standardization. So if each person is doing this in a silo, they might use something different to identify users. One person might use the username, which might be bad because that's PII. Email might be another way, and that's also bad. Finally, someone gets the user ID, and then someone base64 encodes the user ID for no apparent reason, and then you have 4 to 5 different ways of identifying a single person. And so when you're trying to follow that thread through all of the product teams and tying together all this data, the standardization of identifiers and formats is a problem there. And then the final one I'm calling data completeness. So here's an event on the left and that is complete. So we have our account, user, document, timestamp, and our action. And on the right, we have something that's not complete. So there's a null in there. The user ID, which is supposed to be a number, is a string. The document ID is to do because the developer is noticing maybe there's a compile error if there wasn't anything in there, so they send in a string. Our timestamp is actually negative, so this happened, according to this, back thousands of years ago, and the data structure is all wrong for action, and then there's an extra dimension in there. And when we're identifying our data, obviously this data is not going to be usable when you dig into it, right? So those are our 3 issues that we found when we were addressing this problem, and I think are pretty common reading the literature across different organizations. So discoverability, standardization, and completeness. So let's talk about how we solved this problem, and again, remember our disclaimer that this is a way, right? So what if we could build a central location with a list of all the events that all the teams are capturing, with a common set of dimensions, and a well-defined event definition. In other words, strongly typed data, or as I like to say, all aboard the strongly typed pipe train. We've got Rust and Kotlin and TypeScript and Go, and I probably missed your favorite type language in here. But I feel like type languages are making a huge resurgence right now, kind of in the meta of software engineering, and why not apply that to data? So what does that actually mean, and how do we do this? Let's talk about the implementation. So for each event, and let's talk about presentation open. We want to record when the user opens a presentation, saves a presentation. So we'll make a central location for all these schemas, and each schema will have a list of dimensions, and we'll define what that dimension means. So a user ID is an integer. It's required, and it's the ID of the user. Pretty self-explanatory there. for the description. And we can then make this actually into a file, which we can call presentation save. You can do it in kind of any format you want. And we have your account ID, user ID, document ID, timestamp, and maybe if a renamed ID, if someone did save as and saved it as a different presentation name. This looks a lot like a constructor to a class, right? Instructing type language, where you have the type of the variable, and you have the variable name, and then at the end, you've got your keyword arguments, which are optional. And you can indeed take this definition that you've written in any sort of format you want, and you can compile that into a class definition file in Java, or Go, or Python if you're in the back end, or JavaScript or TypeScript on the front end. And you can actually make this into a class. And your developers then know how to actually send. They know what this is. This is a class. Oh, that account ID? Oh, that's supposed to be an integer. Oh, that user ID? Oh, that's also an integer. Next, you make a very thin client that knows actually how to send these events. So we have our presentation save event. Someone has actually passed in IDs for all these things and done the timestamp and the document ID, and then they just do client.send. And you'll want to encode this using anything other than JSON, because JSON is horribly inefficient. And so which one did we use? We used JSON, of course, because it was easy. And after several millions and millions of events, we're rethinking our choices. Okay, so you've got all of your events on this giant data pipeline now. Now we can actually just siphon off 1 out of 100, 1 out of 1,000, 1 out of 10,000, and get a sample of that stream and pass it through and generate a data quality score in real time. And you can track this, and we'll show an example of that. So our presentation save event, you can see on the left-hand side, this is what our developer actually instantiated the class with those values, and the client encoded that in JSON and put it onto our data pipeline. And then our data quality score mechanism pulled it off and now wants to compare it against this definition that it has, that you said you were going to send. So it goes through one by one and tries to do a match. So the account ID is there, it's required, and it's an integer. The user ID matches up, the timestamp matches up, and the doc ID matches up. So indeed, this event seems to pass all of our checks. And you can grade this, 0 to 100, 0 to 1, whatever really you want to do, and you can feed this score directly into your alerting mechanism of choice. So this is the Datadog graph, and this is our analytics score across our entire sandbox environment. And if someone were to do a release and they accidentally messed up all of the account IDs, that score would just take a huge dive and you would get an alert. Navigation page load is our action here, and that had dropped below the 0.8 threshold. And I like to explain this to people. This is just like your grades in school. If you're above 0.9, you're getting an A. If you're above 0.8, you're getting a B. And as soon as you get down into C level, that's when our team gets alerted, and we have the specific category, the specific action. We know the team that's breaking the rules, and we go to them and say, hey, your stuff is really messed up. And that way we get real-time responses to data degradation and quality issues. And this was huge because I'm not sure how many data analysts we have in-house. Anybody? Woo! All right, 0. But if you would talk to them, there's nothing more frustrating than working with your team and getting all these events implemented, and you wait a couple months or a couple days or however long you need to get a full business cycle in. And you go in to do your really cool analysis. It's going to be great, and you're going to figure out who's the most active user and who's a power user. And you get in there, and the user ID is missing on every single event, and you just bang your head against the table because you've spent the past 2 months setting up all this tracking, and now there's no way of knowing which event belongs to which user. With this system, as soon as that score drops below where it should, you're going to get an alert, and you can put things like account and user, it could be 20% of your score, right? And immediately drop you down to that range. So to kind of summarize, a schema registry, right, is an accessible, central, searchable version center for all of your analytic definitions. So things like presentation open, presentation close, presentation save, add a slide, delete a slide, this full rich set, all of the associated dimensions. We can then compile those definitions that you made, and you could use like YAML or JSON or whatever you want. We can compile that into classes in your language of choice. So you can make a Java class, right, called presentation save. Make a thin client that knows how to encode that information and send it using anything but JSON, but maybe start in JSON. And then we have an easy way to check because we have our definitions and we have our data stream, and we're going to check them for quality. Why did I do that? And how does this solve for our common issues? So first, data discoverability. So because we have a central place where everyone's putting these definitions in, right? All we have to do is go there and Control F and search for add, add slide or user or close or delete. Because it's all in a central place, you can make sure that all the user IDs are user IDs and not user email or username or anything that has PII or anything like that in it. And we can use those definitions in the central place to apply a score against your data stream. I'm checking this. All right, so that's so going further. That's kind of like the tip of the iceberg in terms of getting to a minimum viable product of how can we make sure that our data is high quality, how can we make sure that everything that when we're putting data products out, we're building it on foundational good data. Let's talk about things that we can actually do beyond that. So the first of these is enforceable QA rules per dimension. So we talked about our dimension, right? It's going to be user ID. And we could actually go beyond that besides just being an integer and apply some more rules. And the second is kind of data ecosystem that you build up around this. So let's talk about the dimensional QA rules first. So if your field is actually numeric, you could enforce things like it's an integer as opposed to a float. Maybe it's a duration, like how long did it take you to open this document, right? That would have to be non-negative, right? Because you can have a negative duration. Or maybe it needs to be greater than or less than a certain value, right? You could encode all these things in and incorporate them into your score. If it's a string, you could do a length comparison. So our user IDs are between 14 and 16 characters long, or it has to be non-empty string, so the length has to be greater than 0. You could apply against a regex. So if this is an IP address, it needs to have 3 dots, and the numbers have to be between certain values of the IP address. Or you can even do kind of one-of choices. So let's say they are applying or adding embedded content into your presentation. So that's either an image or a GIF or a chart or a table. So one of those. Let's talk about the data ecosystem. So we can kind of break this into the data portal and the reporting pipeline. So the data portal, and this is stuff that we haven't quite got to, but kind of imagine your Google search bar where you can go and I want to learn more about presentations. So I typed in presentation, and it's going to bring up all of the events that have to do with presentation, again, pulling from the schema. So you don't have to go and know about YAML files or know how to parse through JSON files. You can come to this nice interface, search for the events that you want, click on them to actually get further in, and figure out, when they do presentation add slide, give me some more details about that. What dimensions are they capturing? What's the general description, things like that. And the reporting pipeline. So with this data, your organization should be gaining that value, right? So now that we've created all these events for presentation, the sales guys and gals are going in front of people and saying the average presentation user creates 15 new presentations every quarter once they start using our product. Or did you know that we've created more than 13,000 slides in the past month alone? Or your account has done this cool thing. So the actual turning into data, you've made some dashboards and some queries that you're using to pull out this information. And when I need to actually go in and update those fields, so let's say on our presentation save event, we're updating that now because we added a new global ID or something. And so we want to add that to our schema. We're going to publish a new version of our schema, and we're going to say now the presentation open event has a new definition, which will affect the following reports. Would you like to automatically update them to a new version? So you could actually, because this is all strongly typed, right? Just like a compiler goes through, and if you want to refactor a class, you can refactor a dashboard or query with the newest version. And which brings us back to the TLDR. So hopefully this sentence now makes a little bit more sense. What would happen if we took the power of strongly typed languages and applied it to data? And I think I breezed through that a little bit because this stuff started a little bit late, so I was like, but I think we have about, 10 minutes left? So thank you very much, everyone. This is my bling, or whatever it's called, the socials that you can find me on. Are there any questions? Yes. Yeah, so we actually do this, and I didn't put it in the presentation because I didn't think I'd have time. So thank you very much, Donald. Is that David? Sorry. So David asks, in object-oriented programs, we have the idea of composition and inheritance, and obviously composition over inheritance. So what we did is we added this concept of a mixin, and almost all events start with that are on the browser have the browser mixin. And the browser mixin says, I add this list of 6 dimensions. So the first dimension is the browser string, and the second dimension is pulled from that, like the browser ID and the OS and whatever. We also have a concept of base dimension, or base mixin, and that's user ID, account ID, organization ID, date, and session ID. And so for each specialized area that you want to be standardized through composition, you can define a mixin, add a mixins list to your event, and then at compile time, you can just grab all those dimensions that are in the mixin and add it to your list. And now you have a nice, easy building block for building up common event definitions. Yeah, great question. Yeah, so the question was, if your system is based off of API calls, you kind of get a freebie because you could just pull the information off of the API call and just go from there. Yeah, and that's an absolutely great point. What could happen is you could look at your REST API or whatever, and you could almost generate the the event from that, right? And figure out what needs to be sent. And that is another really cool feature that you can do. Most REST calls have some sort of header information that's going to be the same across everything. So you can add that as a mix-in. And you can have your client, you could pass in that header information to your client, and it can autofill fields for the developers so that you may get 8 dimensions for free. Like if you're using OAuth, there's the bearer and the origin. And I don't know anything about OAuth, but you can pull the information out of that. So yeah, two different ways that you can do that. Any other questions? Nothing from David. Yes, so David's asking about incompatible changes in your data versions or your data encoding, or which part of that? Yeah. Okay, so yeah, changing the kind of the signature of the event. So let's say my presentation saved, instead of having user ID and account ID, I now need user base64 encoded ID and account base64 encoded ID for a contrived example. At that point, you have to publish a new version of that event, and like I said, all those events are versioned. And what we actually end up doing is that will end up in a different table in our reporting infrastructure, and you can have your V1 and your V2 of that table. And you pass that on to the poor people who are doing the reporting. So if you, so they have to either look at both versions, and they could potentially do a join against a lookup table from ID to base64 encoded ID, or something like that. But if there are large structural changes like that, usually what we would do is we do additive. So we have user ID and user base64 encoded ID, and account ID and account base64 encoded ID. And you have to maintain that going forward for a while until you can kind of deprecate the old one and switch everything over. In the back. Yeah, so the question is, why did we decide to do the monitoring over the input? So there's 2 places that you can validate the data, right? When that client goes to send it, and you could look at your rules and say, wow, you're trying to send an empty string, that's not allowed, that's out of here. Versus the approach that I put up here on the board, which is we allow them to send that empty string, it gets into our stream with the kind of slightly maligned, polluted data, it feels dirty, and then your score goes down. And our thought there was that even if they do send an empty string for one of the values, we trusted that our developers were trying to do the right thing and trying to send us something, and they couldn't get it. So does that mean we want to stop them from sending us data? And we figured, no, we should accept it, because that data, maybe it's only 80%, maybe it's 60%, but it will have some value to somebody. And there may be a threshold at which it's providing negative value because it's so worthless that it's, but our philosophy was grab everything and accept everything, and then inform people that you're kind of sending us kind of garbage. Well, garbage, quote unquote, because you're missing that field. Right, yep, and that's the other thing, is if someone goes to do their CI and they get 20 warnings from the analytics package, they're going to go, oh, this needs to be out for the customer tomorrow, comment out, analytics calls, oh, my test suite is fixed. And that was another thing that we were very cognizant of. First of all, performance, and if the client fails, it fails silently in production, basically, and making sure that none of that would pop up on any of the radars. So. Yes. So like the context being like, or the question is, how do you take the context of the event? So the context in this sense meaning I'm opening a presentation to review it versus opening the presentation to add some slides or something in this example. Yeah, so I guess the short answer is we don't explicitly, and you should be looking at the event stream from a specific user to kind of see what they're doing in the application that would derive some context from that. So if I'm viewing a presentation, like I send it over to Simon, and he's going to put some comments in there, I can tell that he's a commenter because he's got he leaves a bunch of comments, versus me, who's going in and pasting images madly and resizing them, 10 minutes for this presentation and trying to get everything done. For instance, hypothetically, right? Yeah, thanks a lot. Appreciate it.